Hello, everybody, and welcome to today's VOLTHA 2.10 Techinar. Um, my name is Andrea Campanella from the ex-Open Networking Foundation, now Intel, and joining me, I have Amit Ghosh and Lia Battiston from Radisys. I'd like to first welcome you all, and today we're going to talk about the successful VOLTHA 2.10 release, starting with a little bit of an overview of the 2.0 RD, the VOLTHA architecture, the project states, and the deployments. Then we're gonna go ahead and go into the specifics of the VOLTHA 2.10 release. We're gonna mention the 2.8 long-term support commitment that we have, and then there's gonna be a final part around the transition to community leadership and the new technical steering team. And at the end, we're going to have a little bit of a Q&A. So at ONF, there is a document which is called the CIBA Exemplar Reference Design that is co-written by the key operators that are participating in the ONF efforts and the companies and system integrators and vendors that are also participating in the broadband access venture. And it describes an architecture that encompasses all the different technologies to provide software-defined broadband access solution. Today, we are going to focus more on the controller, so the network controller and the disaggregated OLT management software, which is called VOLTHA. You can go and read about the CIBA reference design in the two links I have added down below here. And in particular, we are going to talk about VOLTHA. So VOLTHA is the virtual OLT hardware abstraction, and it all starts at the bottom with a set of ONUs connected to a PON tree that has the other end on an OLT. And that OLT is usually a white box OLT, but it comprises also of gray box OLTs that has different software on it. And the white box OLT uses ONL, Open Networking Linux, and an Open OLT agent. That OpenOLT agent communicates with a set of adapters that allows us to integrate different types and brands of ONUs and OLTs, because we provide several layers of abstractions throughout the whole system, exposing then an open flow connection to the controller, which in our case is ONOS. This allows us to provide multiple type of services, such as video on demand, multicast, IPTV, HSIA, so high-speed internet access, for different type of operators. So AT&T, Turk Telecom, Deutsche Telekom, and Telecom Italia, for example, with both fiber to the home and fiber to the building capacity. We have also a device management interface that interacts directly with the OLT for non-data path operations of the OLT, such as the software upgrades, such as inventory. We have reached, with this release, 4,096 ONUs per stack. So this VOLTHA stack that you see can manage up to 4,096 single subscribers. And it is capable of doing a software update, both of the VOLTHA stack, in-service software upgrade of the VOLTHA stack, and also update of the OLT and the ONUs. It uses gRPC for intercontained communication and Kafka for the events, and has a huge set of tests in a suite that comprehends all both hardware, scale, and soak testing, and we're going to talk about that more later. It has been released a long-term support with the 2.8, and we have released 6 months ago the 2.9, for which you can see the latest, the previous webinar here. The VOLTHA project, alongside ONOS, is deployed in production with several operators. Two that are being very vocal about their production deployments are Deutsche Telekom and Turk Telecom, and you can read more about that here and in these articles that I'm linking. But at least 4 other operators have VOLTHA-based solutions in several stages of field trial and production. Some of them with actually very big numbers of production deployments, but have been a little bit less vocal about their participation and deployments and their status. So having said all of this, I'm going to hand it over to Amit Ghosh from Radisys, who's going to guide us through the implementation that Radisys contributed to the 2.10 release for the fiber to the building support.
Yeah, thanks, Andrea. Yeah, hello everyone. So I'll walk you through the FTTB support that we added in this release of VOLTHA. So FTTB, which stands for fiber to the basement, uses a dedicated device, which is called as a DPU. And this terminates the PON connection towards the subscribers. So typically this device would be put in a basement where you could connect to multiple subscribers, for example, who are in different apartments. So it could be in the basement of an apartment and connecting to different subscribers. And G.fast is one of the technologies that is used to connect the subscribers to the DPU. So the DPU typically has two parts. One is the G.fast part, which would be switching the traffic towards the subscribers, and the other part, which is connecting towards the PON network, and that effectively is just like any other ONU. Now, as part of integrating the DPU into a network, what the role that VOLTHA is playing is that VOLTHA is responsible only for managing the PON part of the DPU. The DPU, once gets connected to the PON network, right, it would be able to talk over higher layer protocols like netconf and ANCP to talk towards its PMA. PMA stands for I think it's persistent. No, I'm not able to recall the acronym. So effectively, the PMA is the entity which manages all the DPUs, right? And it stores the persistent configuration of the DPU. And this configuration would be something which is on top of the PON configuration. So all the G.fast configuration, the switching configuration for the subscribers, that would be pushed to the DPU from the PMA. But as part of integration through VOLTHA, the PMA is out of scope. And the communication between the DPU and the PMA would happen over a management network, and we would typically use a single VLAN to differentiate this management traffic that is happening between the DPU and its PMA. And all the DPUs in the network could use a same VLAN for this traffic, which means that at VOLTHA, or the way we configure VOLTHA and the OLTs, is that for the management traffic of the DPUs, the switching of the traffic happens based on that specific management VLAN as well as the MAC address of the DPU, which is very different from the FTTH that we already support, where the switching of the traffic happens just based on the VLANs. That being said, the subscribers, the end subscribers who are connected to the network through these DPUs, they will still be handled pretty much the same like FTTH, where each of them is identified by a unique VLAN within that OLT. So the design doc for whatever I spoke about and things where we go into much more details showing the exact flow rules that are configured at ONOS and the way the management VLANs or the PBITs are configured can all be found in the link that is posted here in the Google Doc, and the implementation is based on that. So I would also walk you through a very high level flow diagram of what happens. So the two or three use cases that we have is, one is what happens when we power on the DPU, and then how are the subscriber flows added and removed. So typically, when you power on the DPU, or from VOLTHA's perspective, it is just another ONU, events on the management, the Kafka bus would be sent out, right? And this would be grabbed by this would be or could be grabbed by an operator's component, right? Which knows that, okay, the ONU has come into the pawn system. And depending on the serial number of the ONU, it can identify that it is a DPU, right? Because the operator would know the serial numbers of the devices. So once it knows that, okay, it's a DPU, it would ask to push flows onto ONOS, where it would ask that, okay, add flows on the management and ANCP VLAN. And this is the support that we have added on the ONOS SADIS app. And we have defined different service profiles for the DPU management traffic. So we would populate the SADIS configuration accordingly with the DPU management VLANs and the PBITs and things like that on the tech profile, and then ask ONOS to add the flows. And the ONOS OLT app has been updated to add those corresponding flows. So the first flows that would be added would be to trap the DHCP packets, and then internally it would also use the MAC Learner app to learn the MAC address of the DPU. And once the MAC address of the DPU is learned, it would provision the flow rules to switch the packets based on the MAC address of the DPU as well as on the management VLAN. So once that is done, right, so the remaining part of it is straightforward, right? So it's communication from the ONOS to RW core to VoLTHA adapter and the ONU adapter, and then they are provisioning the flow rules accordingly. So updates have been done both on the OLT and ONU adapter to be able to push these flow rules. So this would set up the management part of the DPU, wherein, can I please go back to the slide? Yeah, so this would set up the management part of the DPU, wherein they can start talking ANCP and netconfig to its PMA. For each of the subscribers, pretty much the same would happen, but here the addition of the flow rules would be for the specific VLANs of the subscribers. And again, we have made some changes to the SADIS services or the SADIS Uniport service so that we can add the specific flow rules. But this is pretty much the same as FTTH. Yeah, next slide, please. Yes, and this one is the removal of a particular subscriber and the power of DPU. So in case of removal for a particular subscriber, again, at the discretion of the operator's business logic, when a subscriber, a FTTB subscriber needs to be removed, the app or the operator's app would talk to ONOS, and it would just be the reverse of the API, the ONOS API that we saw in the previous slide. It would ask for the removal of the FTTB flows, and the rest of it is just the reverse or the complement of what we did for the addition. The DPU power off use case gets triggered again, pretty much like ONU or FTTH ONU, that whenever there is a dying gasp or a ONU LOS coming into the operator's component, it could use that as a trigger to ask the ONOS OLT app to remove all the flows for a particular DPU, and which would include both the management as well as the subscriber flows. And then this application could ask VOLTHA to just delete that ONU device or do a delete device, and then everything gets cleaned up. Yeah, move on to the next slide, please.
Thanks, Amit, for this. Much appreciated. That was very clear. I hope everybody appreciated that as well. In the 2.10 release, on top of this specific integration with the DPU and the FTTB workflow, we also enhanced the scale of the system. We reached 4,096 subscribers on one OLT with one VOLTHA stack, or 4,096 subscribers on two OLTs with one VOLTHA stack. So you can slice it and dice it a little bit how you want, but the goal, the key point is that we reached a higher scale than it was possible before. We also integrated the rolling software upgrade. What does that mean? It means that we leverage the Kubernetes APIs to have no downtime of the pods during an update of a minor version of the pod themselves. Meaning, when the APIs did not change, we're now capable of through the Kubernetes API spinning up a container when we want to upgrade, and we don't have to wait until the first container goes down before it can start serving requests. So there is no downtime of the network being managed during updates. And for ONOS, you can use since actually 2.9 the in-service software upgrade mechanism of ONOS. You cannot do it via the easy API of Kubernetes because ONOS was predates the Kubernetes deployments. But also there you can have a zero downtime of updating the ONOS cluster with new version of ONOS. So this really goes in to support the production deployments, and also the showcases how we can support a 64 ports GPON OLT completely loaded with the ONTs in just one stack. So that's a huge improvement over the 1,024 subscribers that we were capable of handling before. Also, during the 2.10 release, talking about a lower level element, we implemented the initial combo PON support, meaning that we developed a framework for dynamic detection of the PON technology based on the transceiver information. So when that transceiver is plugged in, we read the information of that transceiver, and we can determine if it's a GPON, if it's an XGS PON, if it's a combo PON transceiver. We then configure the MAC and the PON modes in the OpenOLT agent, and that thus through the whole stack of VOLTHA. We report proper port ranges to the VOLTHA core, so the VOLTHA core knows which ports are GPON, which ports are XGS PON, and how to handle them properly. And we also integrated this capability into PBSIM, so we could actually test it. So the idea is that you can deploy the combo OLT with GPON ONTs right now, and then in the future move to XGS PON with the changing customer needs, but not actually having to change the OLT hardware that you deployed right now. We also did a lot of effort in stabilizing the platform in VOLTHA 2.10. We provided an extended OMCI message support that reduces the number of messages exchanged from the VOLTHA stack to the ONU for software upgrade and MIB template, initial MIB download. And this allows us to reduce the time and reduce the number of the weight in the network, in the number of OMCI, the overhead of OMCI message exchanges, and thus resulting in a higher download speed, for example, for the software upgrade with a lot less time taken in upgrading the ONU, so less downtime for the customer. We also introduced unknown ME handling, meaning that we now use a relaxed decoding of the unknown MEs, and we discard the unknown entities, but proceed with the ONU MIB download for that ONU without having to stop downloading the MIB for those ONU. We also integrated ONU delete and automatic rediscovery, resource cleanup in the TCD and ONOS, and a few bug fixes were included by upgrading to ONOS 2.5.8 as a base. In general, the idea is that we have a better overall handling of new ONUs and better code quality and extensibility with a longer lifespan of the whole system. Basically, we stabilized even more the project for the next releases and the next production deployments. With that, I'm gonna hand it over to Elia, who's gonna talk about the ONF BBF collaboration and how we worked with BBF to integrate their models into a component that is able to talk to VOLTHA. So Elia, take it away.
Thank you, Andrea. As part of the ongoing collaboration between the Broadband Forum and the Open Networking Foundation, we started the development of a component called VOLTHA Northbound BBF Adapter. And as you may know, the Broadband Forum's Cloud CO architecture, which is defined with TR-384, describes a set of standards and guidelines for a disaggregated central office. And VOLTHA fits in this picture as it can be considered an example of a broadband access abstraction layer for PON or BAA layer for short. However, VOLTHA APIs are not currently compatible with other components of Cloud CO, which primarily use netconf for their communication. And so the VOLTHA Northbound BBF adapter or BBF adapter has the goal of receiving netconf requests from its northbound and perform a translation to the equivalent operations for VOLTHA, allowing the stack to be controlled from a BBF compliant access management and control component. To make this possible, a set of young models that capture the information used by the northbound VOLTHA APIs is also being discussed. The work on these young models started by targeting a set of operations for an initial support, and these include retrieving a list of managed devices, provisioning and enabling ONTs, and provisioning and removing service subscriptions, for example. And mapping the information provided or requested by this operation showed that a great part of the devices related information can be captured with standard models defined, for example, by BBF TR-383, like BBF device aggregation, and other IETF standard models, such as IETF Algor. The description of services, on the other hand, was less represented by existing models. And for this reason, augmentation to some BBF models that are not yet standardized has been proposed and is currently being discussed. Slide, please. Thank you. Thank you. For the architecture, in this slide, you can see a representation of the architecture of the BBF adapter that will be deployed as an additional microservice along the existing VOLTHA stack. The adapter's container exposes an instance of Net2Peer2, which is an open source netconf server, and takes care of the netconf protocol interactions with potential clients. Net2Peer2 is highly integrated with the sysrepo data store, which manages and provides the configuration data, which is organized in young schemas. And this data will be requested or modified by the netconf clients. The translation logic will be provided by the actual BBF adapter process. You can see it at the bottom, running as a sysrepo plugin. And this means that the process registers with the data store at startup and will be informed of any netconf request which is acting on VOLTHA related young models. And the BBF adapter process has been developed in Golang for consistency and to leverage tools already developed for the rest of the code base. Since sysrepo offers no bindings for Golang, their interaction has been made possible by using libsysrepo, which is its C library, used through Cgo. When one of the relevant requests is received, the adapter uses its gRPC connection to VOLTHA and the REST APIs to ONOS to perform that task. Even though sysrepo is a data store by nature, the goal of this adapter is to be a purely stateless translation layer, which is always retrieving the latest state information from the VOLTHA stack to avoid the synchronization issues. And the current version of the adapter, released with VOLTHA 2.10, only supports the retrieval of managed devices, but lays the foundation for the complete functionality that will be supported in upcoming releases. So its development is in progress with the goal of showcasing the results of this collaboration at Broadband World Forum 2022. Thank you. Back to you, Andrea.
Thanks, Elia. And yeah, this is a great effort that was put together with the BBF team, and it's an ongoing effort. So what you see here is just a seed, as Elia mentioned. It's just a beginning of a much better integration of BBF and ONF of our code and their APIs that is going to continue hopefully for the next foreseeable future and help both them and us make better APIs and better code for merging them. Also, the Yang models are going to be, the suggestions to the Yang models that we made are going to be contributed officially to the BBF Yang models through the BBF contribution process. So I really appreciate this getting together of these two organizations that work on broadband. So having said that, I would also like to talk about testing because it's a fundamental component of VOLTHA and how we manage to deliver a proper set of containers for the release, and also to keep the quality and the capability of the software always available. We introduced in VOLTHA 2.10 tests for FTTB on BBSIM and on actual hardware. We added memory leak tests and tests for the functionality of the ONU adapter, such as the unknown MEs and the extended OMCI message support for MIB upload, MIB audit, and MDS mismatch. We also added the ONU delete and rediscovery test. We integrated the Mac learning capability in the Turk Telecom sanity test, actually reaching the full-fledged Turk Telecom workflow with Mac learning in the sanity that is run per patch set. We also started testing the device management interface on top of the Adtran DMI adapter on the Adtran OLT in Berlin. We included rolling upgrade tests, and thanks to great contributions from a group in Italy, we included the Telecom Italia workflow tests. So now we have a basic sanity for the Telecom Italia PPPoE-based workflow. We also included the unknown attributes test. We have included a nightly, the nightly scale and 180 plus hardware tests that you can see them, and you can see them at on Jenkins. What I want to showcase before I move over to the next topic is the number of total tests that we run per night. So I made the count, and it's 1,134 nightly tests between emulation and actual data plane hardware or physical OLT tests. It includes soaks, a soak pod, and it includes scale. This is a huge number. This is a number of permutation of some tests that we run per workflow. So it's 7 hardware pods with 7 different OLTs certified, 5 different brands of ONUs, a DPU that we added, and that runs all of these different workflows for Turk Telecom, for Deutsche Telekom, for Telecom Italia, and for AT&T. And as I mentioned before, this is the only way we manage to be capable of releasing the project and keeping the quality of the code high during the whole release, and also adding new feature and new capabilities without breaking what was there before. So speaking of hardware OLTs, in VOLTHA 2.10, we also added in the continuous certification program the Zyxel SDA 3016 SS combo OLT. It's a white box OLT. It's a 16 combo port, has 16 combo ports. It works with the OpenOLT agent and adapter. It's BAL based, it uses ONL, and it integrates in VOLTHA as the other white box OLTs that already are included in the system. It has temperature hardened, and it's an x86 based CPU. You can find more information at the link that I added here. And a huge thanks to the Zyxel team for working with us in integrating this OLT in the continuous certification. So this OLT will be certified on 2.10 in the upcoming releases. Speaking of continuous certification, we also continue to certify the different other OLTs that we introduced in the past releases, such as the Edge Core, XGSPON and GPON, the Radisys 3200G, 1600G, and 1600X turn in GPON mode, The Adtran SDX3220, also in GPON mode, the Zyxel OLT in GPON mode as well. And we use the Zircom FG1000, for example. If you want more information, you can go to the marketplace and you can find more data and more devices, even more devices such as the aggregation switches in the ONF marketplace. The last element that we touched upon in the 2.10 release is the ONOS replacement architecture. So ONOS has taken us this far in the VOLTHA project and has taken us to production. It has proved its quality in the production deployments, but as people that work in software know, after some time, you find out what exactly you need. And ONOS was also introduced in the project at a point in time where the scope of the project was much bigger. So right now, during discussions, we figured out that we wanted a way to reduce the scope of the controller to just VOLTHA, go away from the OpenFlow abstraction and just use the VOLTHA APIs. All in all, reducing and making a smaller footprint of the controller, with the capability of restarting without a multi-instance, with lower footprint in terms of resources. So we started a design discussion, and what you see here is the outcome of that design discussion. I'm not going to go into detail here. I would encourage you all that are interested in this particular topic to reach out to the technical steering team and watch a few recordings of the last technical steering teams where we actually did discuss this. And the idea is to have these different components that are still loosely described as the ones we have right now and mapped to the ones we have right now, but rewritten in a language of choice that will be decided, and that will definitely communicate to VOLTHA through the VOLTHA protos, and that are going to still use the SADIS and still expose the APIs to the OSS BSS. Both Radisys and Netsia have working controllers deployed in production that are loosely based on this architecture. Radisys has open source their controller, and I added the link there. So a huge thanks to them for deciding to open source their controller as a possible implementation of this architecture that I just described here. And if you're interested, really just participate in the TST to make the decisions that are going to take this proposal forward in the next release. So let me recap a little bit what we did as an accomplishment in VOLTHA 2.10. We integrated fiber to the building with DPU management with ANCP traffic and rules for a subscriber and DPU management with an Adtran DPU in hardware testing. We enhanced the scale with to 4096 subscriber per VOLTHA stack. We introduced the rolling upgrade, an initial combo PON support framework, the extended OMCI message support for higher speed of software upgrade and mid-template download, unknown ME handling, ONU delete and rediscovery. We developed the BBF initial adapter with an initial implementation and the contribution to the specific models that BBF has. We moved to ONOS 2.58 with bug fixes and platform stabilization, and we certified new OLTs. If you want to learn more about all of these different components, you can go and read the release notes that I linked here. As usual, they're under the docs.voltha.org website. That is where we publish our documentation. So having said that, we also introduced more than 15 fixes between the different code bases and the tests for the 2.8 long-term support release, which was 2.8. So we committed to supporting 2.8 for a year and a half. This is the 1-year anniversary of 2.8. It was released June 30th, 2021. And during the 2.9 release, we added more than 50 fixes. Right now, we added more than 15 fixes. So the long-term support release, the 2.8 release, is really, really stable and is really, really in prime time and is already used in production in several operators. We did that by adding Helm charts and new documentation, fixing them properly according to the different versions of the components that we updated. And we also will continue the support for 2.8 until December 2022. As I said, a year and a half since the release, which was in June 2021. With all of this, I want to give the floor to Timo Sloan from ONF, who's going to talk about the next steps for the VOLTA project in the context of the Open Networking Foundation.
Andrea, thank you. And hi, everyone. Hi, I'm Timo Sloan. I'm the general manager of ONF. And Andrea asked me to join today to just, talk about VOLTA in the context of the broader ONF organization and the ONF portfolio of projects. And ONF has been going through some transformation that many of you have probably heard about. And I just want to take a moment to be able to talk about that and be here to address any questions should there be some. So just maybe about 4 minutes for some content on this. Andrea, please forward away. Good, thanks. So the first thing to note is that ONF has gone through a few major transformations in its journey. We're really, going through into what we call phase 3 now of our journey, into what we're calling the adoption era. And we went through the OpenFlow era. You even heard OpenFlow being, discussed today, and then some movement beyond OpenFlow with sort of the updated lightweight controller for VOLTA. We've been, in this phase 2, a platform era where ONF, built, resourced an engineering team and focused very inwardly on driving projects forward, VOLTA included. And we believe that across the ONF portfolio, we've really reached a precipice. And the projects are getting adopted. VOLTA is getting used in tier 1 production networks worldwide, and that to grow the next 10x for ONF to really scale, that the model needs to shift. We need to shift from an inwardly focused to an externally focused, community focused model to be able to grow and scale. Please click. So to that end, the current model, or the phase 2 that we're exiting, was really funded by 2 primary sources for the engineering team. There were a set of ONF partners that funded at the $500,000 or $1 million level, and then there was also some funding from a DARPA project called Pronto. These were both about 50-50 of the funding that was really supporting the engineering team, that was in turn making the about 50+% of the contributions to the ONF projects. And if you click, in phase 3, we're moving to a model. The vision has been to move to a model where the community is much larger, and the community is making the bulk of contributions to the projects, and the overall number of contributions scales. That ONF is still playing a critical role, but is focused more on DevOps and release management and enabling. And so in this transition that we've announced now 3 months ago, that Intel has acquired the spinout you may have heard of, Ananke, and also Intel has hired and subsumed the majority of the engineering team from ONF, as described in this arrow. And if you'd click again, the anticipation is, the plan is, what's happening is that DARPA funding is moving to Intel, and that DARPA funding stipulates that all that work goes into open source, and so it kind of continues to flow through into the contributions and into the ONF projects. So what we've done is effectively moving a number of the pieces around, a transformation where people are switching hats and roles are shifting some to be able to embrace this phase 3 of our journey. Click again, please. So, the organization has also shifted to accommodate this new model, and I don't want to go through a touch of detail here in the interest of time, but number one, the board is the same. We're still backed. Andre Furich, the CTO of AT&T, is still the chairman. And notably, I want to call your attention to the left side of this diagram. This is where we're creating a new governance model to really enable the community to help drive the projects more. And in particular, the upper left there's a broadband box, and we're creating a new broadband area governing board, and the VOLTA TST and the SIBA RDT reference design team sort of roll up into this new board. We are in the process of launching that board now. We have a meeting in about 2 weeks in Ankara with Turk Telekom and Deutsche Telekom and others, a set of vendors, and we're getting that up and running, and you'll hear more about that shortly. And then you'll see that roll across the rest of our portfolio as well. So, and if you click again, so just talking about these 4 areas that I mentioned, sort of area boards for these 4 areas. Again, I don't want to go into a lot of detail here, but the 4 major areas are broadband. That's what we're here to talk about today, and what you're maybe most interested in, given that you're here. But we also have an Open RAN portfolio of work, private 5G and edge cloud portfolio of work, and then programmable networks. We have a set of goals and ambitions for all these areas. And I just want to mention those goals for broadband, given their relevance for this group today. So you'll see that number one, our first and primary goal is to get VOLTHA under solid community leadership, and to support the growing adoption and support the operator deployments. And you can see that here. You're going to hear more about that from Andrea in a moment. We also want to recruit additional operators to go public with the way they're using VOLTHA. I think Andrea dropped a few names or hints, but we know of public activity, or not public, but operator activity, even tier 1 activity. They're just not public, and we think it would be good for the community for it to be more broadly known, the scale and scope of VOLTHA's traction. Where we want to recruit and bring more PON vendors, and Andrea mentioned a PON vendor today who's now certified, Zigzone. So we're already seeing great progress there. And lastly, alignment with BBF, and you heard there's some traction on that front as well. So I think that we set these goals out more than a quarter ago, and we're making good progress on this and various fronts. Click again. So just in closing, for my part here, I just want to mention that we called for a broadband meetup in Berlin, and we had an amazing turnout. We actually sold out capacity. Given COVID, we had to limit the exposure and room size and all of that. But it was really wonderful to see the community come together. A lot of enthusiasm. Great to see people face to face for the first time in 2 years. A lot of energy, a lot of commitment for VOLTHA and related projects and activities. And I'm really looking forward to a really exciting year and more to come. Thank you.
Thanks a lot, Timon. That was really a good recap of what's next for ONF, and it's exciting for the organization. So having Timon presented what the broadband meetup in Berlin that happened, and a lot of talk about the community, I don't think we can leave with this webinar without recognizing the great effort that went into this release and into the whole project from all of the companies that you see here. And as Simon mentioned, there's going to be a transition. I will also be part of that transition, so I will not be leading the project anymore. And starting here, I would also really to thank from myself, from my side, and from the ONF, ex-ONF team, but in general from the project at large, the whole great contributions that were made by people in this set of companies. And I mean, listing them all would take me an hour probably, but you all know who you are, and you all know the great contributions that you have made. And so a real heartfelt thanks to everybody that contributes in the project and still goes on day by day in making it better. And that this is really the people that make the project. I'm here talking about it, but there would be no project without this great community. And this is the community that is going to be empowered by this new phase of ONF. And it's the community that's going to take it even further in the new deployments and new scenarios. So my personal thanks, as this is going to be, as I said, the last webinar that I joined as a lead of the project. And a huge thanks to my team and the team at ONF that put this forward within the Open Networking Foundation. And there are going to be changes. There's going to be new people that come in to help the VOLTHA project. But all of these folks that you see here transition to Intel. And I would just have a huge thanks to Grish, Hardik, and Matteo for the great work that they have done, and the great contributions that they have brought to the project. And a huge thanks also to Surf for mentoring and leading us as a manager and as really our mentor for the PON project in ONF. So a huge thanks from my side I think everybody that has worked with this group recognizes the great value of these guys. So a huge thanks to them. And also, before I open up for questions and answers, I would like to introduce you, to thank for their contribution, because they've always been very active in the project, but also to introduce you to the two new TST leads. So the technical steering team now has two people that are co-leading it. One is Amit Ghosh from Radisys, and the other person is Mahir Guniel from Netzia. They represent Deutsche Telekom and Turk Telekom and their interest in the project as well. And they have been involved in the project far before I was. So I think they are the perfect couple of person to lead the TST and make the next set of great decisions for the project. I left the email here. I added it so you guys can reach out if you're interested, and I would really encourage you to do so that they can help you participate in the project and join the TST. So with that, I would like to thank you. If you're interested in joining TST, it's Tuesday at 8 a.m. Pacific Standard Time. The link is there. If you're interested in starting with VOLTHA, you just don't know where to go, docs.voltha.org. That's the perfect place to start from. And in there, you can find our email, the people that presented today. So myself, Elia, and Namit. If you have any questions or any comments or thoughts, just feel free to drop us an email. Before I finish, I would like to remind everybody that this webinar is recorded, will be shared on YouTube with the slides. So you will receive an email because you registered with the link of the recording and the slides that we presented today. I forgot to add Timon's email here. Sorry, Timon, my bad. It's just timon@opennetworking.org. So if you want to reach out to him, that's his email. So now I would like to open it up for questions. And there is a Q&A section in the bottom of the Zoom. So if you want to type your questions over there, we can definitely answer them. And I would encourage everybody to take the opportunity of having us here to ask us any questions or provide us any thoughts or comments that you have. I would also encourage everybody else that is here to open up their video for people to see them while we answer questions. I hope everybody can find the Q&A button on Zoom. And if you guys have any questions, just feel free to post them there. We're going to pause for some time and wait for the questions to come in and then start answering them. Also, the one came in and it says, I would like to know about NEM. Is it still available as a management tool? So I can take that. The software for NEM is still available and still present at ONF. And it has not been updated to the latest version of VOLTHA, that I have to say. And that is because the focus of the ONF team and the community at large has been really much into creating the PON side abstractions, because we wanted to focus on a narrow element that we could make very good. We realized that while working on all of these different elements, NEM, the BNG, the fabric, and VOLTHA, our resources were too diluted. So for now, we did not update NEM to the latest version of VOLTHA. If you're interested, the contribution is more than welcome for you to take that and move it to the latest version of VOLTHA with the new latest APIs and then deploy it on top of the same Kubernetes cluster. If you want to do so, feel free to reach out to the TST or to Timon to know where to start. So next question is, will the ONF continue to promote the adoption of VOLTHA project, attracting more operators and vendors? I think, Timon, do you want to take this one?
Yeah, happy to. Yeah, the answer is definitely yes. You know, VOLTHA is a big success story for ONF. There are operators that are dependent on it, you know, very significantly. And so, you know, we have a healthy, strong community, and ONF is definitely here to back it. So, you know, ONF is going through, you know, something of a transformation, but is still, you know, driving and supporting the project just in a different way, in a way that helps embrace and support and is more inclusive of the community. And I would add that part of what we're doing is, ONF is still running a CI/CD pipeline for VOLTHA and for all of the projects. And part of that is a lot of infrastructure that runs in the cloud, infrastructure that runs in colos that ONF runs, and infrastructure that runs in community labs in Berlin and in Oregon, where the OLTs and other hardware are actually installed. And we are staffing, a team that supports and backs that, keeps it up and live. That's the backbone of our continuous certification program and all the tests that Andrea was talking about running nightly against all the gear. There's a live dashboard that shows you the health of the gear, and that all sort of directly feeds into the marketplace that then is the first stop for operators that are looking for components to build their own solutions in their own VOLTHA solutions. So ONF is 100%, 110% behind that, and will continue to support and promote.
And to add to that, we actually encourage everybody that wants to join, like new vendors and new operators, to come in and talk to Timon, talk to the TST leads to get started, how to get engaged, and how to properly get plugged into the community. So the second question is, there was another question that says, the VOLTHA features around layer 2. Some operators are evaluating layer 2 versus layer 3 MPLS options at the OLT. Does VOLTHA have any plans for supporting layer 3 MPLS at the OLT? So the short answer is yes. There are plans and thoughts about supporting layer 3 MPLS at the OLT. And we actually started thinking on how to do it. We did pause the activity because it was not of the top priority. Maybe Amit, do you want to give us some more context on this, given that it was Deutsche Telekom requirement?
Yeah, absolutely. So you are correct. So we did start on that, and we started designing on it. And the design doc is, I think, pretty much up to date till the extent we discussed, and it's still up there as the Google Doc. I can share that link. But yeah, from an implementation perspective, I think somewhere it got deprioritized because the design was done, but there's no immediate requirement of this feature for an implementation perspective, and that's why it's still waiting. But I think from a design perspective, we're pretty much out there.
So same as every other thing, and I keep repeating myself, but if you're interested, there's definitely appetite in the community for it. And if you do have resources or you're interested yourself in contributing, just reach out to Mahir, reach out to Timon, reach out to Amit, and we can definitely start from the design document, expand it if needed, and then take it from there. Okay. Any other questions or comments that people want to make before we close, given that we are almost at the top of the hour? Okay, then if not, thanks everybody for joining, much appreciated. And thanks a lot for all the great contributions, everybody who participated in the 2.10 release. And I hope to see you contributing again in the 2.11 release. And I know the project is in great hands in Mahir and Amit's hands, and with the great supervision of Timon. So thanks a lot for all the contributions and all the participation. And until next time, goodbye, everybody.